member calls up, wants information about the NAA. I gave him information about the NAA, and all of a sudden, the next thing I know, he's here. And not only is he here, but he's working on building his own PBR. Okay? So, it's guys like this that we need in this organization. So, I just want to bring him up, and he's going to just talk to you for a few minutes. I know everybody's got to catch planes and everything, but I want him to talk to you a little bit. I have no idea what he's going to say to you, but anybody that is is in college and is out there and very shortly is going to be coming into this industry, I have to admire, and I want to give him some time. Okay?
Well, the first thing I want to say is that I want to personally thank all of you for being here, and especially for the people that have charitable donations to the NAA. I personally wouldn't have been able to be here if it wasn't for the generosity of you folks, and the information I've gained and the people I've got to meet, it's invigorating and it's priceless, and it's worth a lot to me. And frankly, whatever you guys can do to reach out to younger generations, such as myself, just getting into the workforce, let's start getting programs in algae biofuel engineering. Let's start it up at colleges. Let's even go down to the high school level, because I think the innovations and technologies are going to come from not only tried and true tested technology and people with a lot of wisdom in the field, but those guys that get in there and have fresh ideas. So, algae. When you think about it, basically, people have been trying to kill it for years. And if I were to ask you about 5 years ago, hey, 5 years from this date, you're going to be at an algae conference, you'd probably shake your head at me. And the fact is, the definition for algae off Webster's is up there. Contains chlorophyll, carry-on photosynthesis, basic building block of life. But I basically like to redefine algae and say that algae is going to be the transformational technology for our future. And you have your traditional definition of an entrepreneur, person who organizes and manages any enterprise or business. But I'd like to say, I'd like to do my own definition, and I'd like to say that people like Bruce and Barry and Fernando, all these guys, these are the entrepreneurs. And really, we're not exactly entrepreneurs. We're entrepreneurs. And so, just like Barry said, $2.5 billion of research from the Fed and, institutions haven't gotten us anywhere. It's going to take hard work and rolling up your sleeves to really make this a possibility for our future. And so I'd like to roll up my sleeves and start to tell you about what I'm doing at the University of Denver. Or go back to the beginning of the presentation. Alright, so basically, I have designed an algal airless draft tube photobioreactor for Phaeodactyl and Trichonis research with the help of my esteemed colleagues, Daniel Smith-Blake, Reese Anderson, Tracy Scan, Elliot Tippin, and Andy Young. We're a team of 4 mechanical engineers, 1 computer engineer, and myself, an electrical engineer. We'll all be graduating June 5th, and we hope that, if you ever in Colorado, you can stop by, come see this, and we're going to get some videos of this posted. Actually, next week, we're beginning construction. So it's an exciting time. We've been designing for about a year, and we're excited to present this to you. In my presentation, I'm first going to go over some engineering design criteria. I think it's important to have basically an engineering design process as you go about bringing these technologies to life. So I'm just going to go ahead and go through what we do as engineers, and that'll help you guys develop your products. Then I want to talk about the biology of our algae and some important implications that you may not have considered about the algae. Next, leading into you have to do a capstone course in engineering to graduate. Well, we are fortunate enough to be pitched a project by Lockheed Martin to help develop algae biofuels. So this is a partnership between Lockheed Martin and the University of Denver. And when they came to us with this project description, this is the only requirement that they gave to us. Basically, they wanted a scalable design. They want to be able to commercialize it and scale it up. It has to be designed for continuous 24-hour operation, ingestion of CO2, and require nutrients. So basically, they want fully automated, complete system that's able to have accurate environmental conditioning and sensing. And so the next stage in the process, basically, the next step is your requirements formation. And so this is a really important contract that basically, you practice in business all the time, I'm sure, but I'd like to just explain how our requirements came about. So basically, it's an iterative process working with the client. You got to have as much communication as necessary to ensure that you're going to get the product that the client wants. You don't want to over-design and spend a ton of money, or under-design and not deliver the performance that they are going to need. So the next phase, once you've got a clear, concise, and understandable requirements document, you brainstorm conceptual design. And at this point in the design, you don't want to throw away those crazy ideas. Those, maybe you could, grow your algae with bioluminescent algae or something. But it's those sorts of crazy, out-of-the-way ideas that sometimes have validity. So at this stage in the process, you need to then determine your engineering specifications and really get a grip on what's feasible, and do your rigorous engineering analysis to come up with your design. Pitch those designs against each other, take the best ideas, and then come up with your product. And really, if you go through this process, it's not a linear process. You got to return to each stage as you go through. And so I think that the algepreneurs at this conference can benefit by a lot of open communication and dialogue, which is why I'm thankful that Barry has started to push this technology. Otherwise, I think it'd still be in the lab and in the research papers if you browse through the periodicals on the web. So once you have a solid set of requirements, like I was saying, you have your performance and functional requirements. So the functions are what you look at to basically come up with your design, and those are directly related to your requirements. And so you want to make sure that it's unambiguous, complete, verifiable, consistent, and traceable. And so an example with two requirements for us, if you're interested, we have about a 2-page requirements document. That system should operate at water temperatures from 60 to 100 degrees Fahrenheit, plus or minus 2 accuracy. And there will be notifications to users with a change grader plus or minus 1 NTU, which is a turbidity unit. And I also wanted to point out a unique piece of software that actually auto-generates your traceability. So if you're programming with LabVIEW, you basically write a little VI, and each VI virtual interface can perform the desired function. You can use this add-in easily to generate your requirements traceability, make sure you deliver your product with everything that the customer desires. And so this basically was the iterative process I was talking about earlier.